The T92 was the first tribometer that we designed to be exclusively PC controlled. That was back in 1994, and the computer software and hardware was our compen system and our second generation computer interface. At the time, we reflected this in the name we gave the machine, T92 microprocessor controlled rotary tribometer. Current machines are still controlled by compen software using our latest generation microprocessor controlled interface. On the machine, load is applied by servo-pneumatic bellows with force transducer feedback. Two sizes of bellows are provided, one giving a load range of up to 1,000 newtons and a higher capacity unit giving a load up to 10,000 newtons. Changing load range is a simple matter of removing one size of bellows and replacing it with the other. Perhaps the most common form of rotary tribometer is the 4-ball machine, and tooling is provided on the T92 for running tests under fully automatic control. The rolling 4-ball test was originally developed by Doug Scott and Fred Barwell at the UK National Engineering Laboratory sometime in the 1960s. Much of the work was done on a Plint TE82HS machine that just happens to be the predecessor of the T92HS. Over the years we have made various non-standard size rolling 4-ball test adapters, the latest being one in which inch balls are used in conjunction with a cage and a more acute contact angle. For sliding tests with area contact specimens, we have 4 standard test adapters, starting with a heated test bath for lubricated tests. For dry tests in 3-pin-on disc and thrust washer configurations, we have an adapter with a centrally located capacitance probe for non-contact online wear measurement. For dry tests at up to 600 degrees C, a heated test enclosure is available. Finally, we have a bath which combines both heating and cooling. Compatible tooling inserts are provided covering 3-pin-on disc, thrust washer, LVFA and face seal, Suzuki test, vane pump, three-pad thrust-bearing Tribometer tooling, and pump slipper shoe tooling. For rolling contact fatigue tests, a test bath with an integral self-aligning bearing is available. Test adapters include an arrangement in which a cone is loaded against one half of an angular contact bearing. In this case, the cone material is the test sample, and silicon nitride balls are used in preference to steel ball bearings. The thrust ball bearing on disc arrangement uses part of a thrust ball bearing and a test disc of specimen material. A third arrangement uses a standard roller thrust bearing, once again run on a disc of test sample material. All three arrangements can be used for testing complete bearings. Used in conjunction with modified cages, tests can be run either with continuous current or with periodic electrical discharge. Interesting results can be generated by limiting the number of electrically conducting rolling elements to 1. Significant damage can be generated in a very short space of time. The pin-on-V block and block-on-ring adapter turns the machine from a conventional axially loaded machine into a radially loaded machine. This is achieved by loading two specimens on either side of a rotating shaft or pin, hence producing no net radial force on the machine spindle. A precision low load adapter is available, extending controlled load down to approximately 1 Newton axial force. This is typically used in conjunction with an electrochemical cell. The low load actuator incorporates an air bearing. The machine is equipped with a potentiostat and is fitted with a Faraday cage. A range of more specialized test adapters are available, including a 3-station ring-on-liner adapter, in which ring sections are loaded radially against the inside of a section of cylinder liner. The 3-ball-on-rod rolling contact fatigue adapter allows rolling contact fatigue tests to be run on rod samples of bearing material. The KRL adapter is for running standard shear stability tests on lubricants and greases. The cone-on elastomer ring test adapter is for running tests on seal materials using an idealized and simplified test geometry. The orbital spherical bearing test adapter is for measuring the friction vectors on mechanical and human joints subjected to orbital motion. The lip seal adapter is for measuring lip seal friction and for observing leakage past the seal. Let's now move on to the drive options. The G92 comes in 2 versions, a standard speed version with speeds up to 6,000 RPM and a high speed version with speeds up to 10,000 RPM. Both machines have 2 speed ranges achieved by having interchangeable drive belts. Both machines have 2.2 kilowatt motors, but with the option to upgrade the power capacity to 4 kilowatts. A mechanically driven oscillating drive mechanism is available on both machines. standard motors will not normally run smoothly at very low speeds. To allow precise control of low speed motion with a continuous speed ramp up to, say, 3000 RPM, we have the option of fitting a geared motor in parallel with the normal machine drive motor. This is connected to the machine spindle by a sprag clutch. From 0 to approximately 75 RPM, the spindle is driven by the gear motor. Above 75 RPM, the machine vector motor takes control and the gear motor is disengaged by the sprag clutch. This provides very precise control over motor speed from 0 to the required maximum. The speed ramp and smooth transition works in both directions. And finally, in addition to the standard T92 and T92HS, we have one further derivative, the T92M clutch friction test machine. This has enhanced low speed, high torque capabilities. For further information on the T92 and T92HS, please either contact Phoenix Tribology Direct or visit our website.